All right. That's good. What's up, guys? Y'all hear me in the back? Yeah. Thank you all for coming out. This is our third and final cluster of the quarter on linear and logistic regression. My voice is kind of patchy right now, so if you can't hear me, please let me know. Just raise your hand. I'm more than happy to go over something again, or at the end, come up and just talk to me over here at the end. That's why. So once again, thank you all for coming out. If you have questions because you can't hear me, just let me know. And we're also recording this, so after the meeting is done, you can check it out on the recordings channel in Discord, and it'll be up on our drive as well. So let's hop into it with linear regression. So what is linear regression? So pretty much what I'm going to do is I'm going to define it, give you guys what it is. I'm going to ask you, where do you guys think we can use it? So the what, best fit line, a line of best fit. You have a data set, and I want to create a line that accurately maps the trend of this data set. And let's say I want to forecast something in the future. What about this point that's out over here? What could that point look like with this line, right? So based on that, where do you guys think we can use something like this, real world applications wise? Go for it.
Making predictions based off of improved data.
Sure, in some cases, sure. Anyone else? Going once, going twice. No? All right. Pretty much the basis of it is we want to be able to analyze a trend, and we want to forecast a certain point in the future. That is the way I like to think about it. And that's the way that a majority of you guys, it'll land easier that way. So in very layman's terms, all we want to do is fit a line to data. We want to find some correlation between the independent variable and our dependent variable, right? So the basics, we want to find the line of best fit, and really what we want to do is we want to get this equation right here, y equals mx plus b. It sounds very simple, and it really is that simple. I mean, we've been doing this since like algebra 1. You get a data set like that, you see it on your test, and they'll ask you, how do you, let's draw a line of best fit here. And you look at it, and we can just eyeball it. Be like, all right, I think the line will probably go somewhere around here, right? And you'd be right. But we know that. The computer doesn't know that, right? So how can we get that line with the computer rather than us being like, all right, I think it works. And now is something that's called least squares regression. All right. I'm on my Heisenberg ball. I'm on least squares regression. All right. How does it work? Very simply, we want to set down a line, measure the distance from each point to the line, square all those distances, add them up, and pick our least sum. That line will be our line of best fit. So let's see it in action. Let's pick a point. Let's pick a line, any line. It could be here, it could be up here, it could be over there, it could be anywhere, right? What we want to do is let's just create any random starting point for our purposes. From here, oh, what the heck? From here, let's take a point and let's find the distance from that point to the line. This distance is called a residual. You're going to hear me saying that term a lot, but all it is, it's a scary word, but all it is measuring the distance from this, from a point to the line. That's all it is, right? So we're gonna do that for every single data point here. We're gonna find the distance and we're gonna square it. We're gonna find the distance and we're gonna square it. And let's add them up at the end, all right? We're gonna square all these distances, add them, and let's create a correlation to that line. So for this line over here, let's say this value is about 100, all right? Then this value over here it looks more accurate to our data set, right? So this value will probably be lower, right? So what we want to do is we want to continue repeating the process until we have our least squares, our sum of least squares, all right? Once we find that, we found our line of best fit. Well, how do we know which way to go? That process is something called gradient descent. That is what we'll be doing next time. In our deep dive meeting, will be more of you guys seeing hands-on how this works rather than me up here explaining it to you guys. So which one do I pick? I'm picking the one with the sum of the least squares, right? All right, so to recap, we're gonna set a line, we're gonna measure the distance, square them, sum them, and we're gonna find our line of best fit. All right, let's try it here on this data set. I'll pass the pointer off to one of you guys. If you guys can like draw like an accurate line of best fit. I need one volunteer or a couple of volunteers. Hands. No hands. Yeah. Here. Or actually, here. I don't want to throw it. If you could draw a line of best fit on that, where would you think it would go? There's like a bottom one. Yeah. Yeah, there you go. Yeah. Yeah, something like that. So that's on our eyeball estimation. What if we did the same thing? What if we did the same thing, but with our least squares regression that we just talked about? What if we accurately put a line of best fit down the middle over here? So we're gonna pick a line, we're gonna find the residuals, we're gonna square them, and we're gonna find that our line of best fit is somewhere around here. All right. So this works-ish. We're trying to figure out if, based on this data set, based on the weight, is the person obese or not obese? All right. And if I go down the line, way over there, or let's just keep it with these points here. If my value, let's say if this is my 1, this is my 0. If my value is less, if my xy point is, my y point is less than 0.5, I'm going to say the person's not obese. If the person is greater than 0.5, I'm going to say the person is obese. And for this, it somewhat works, right? But what if I put a point way out over there, like just way over there and all the way around, right? What if I did that? How would that change the line? The line is all of a sudden going to flatten, and the way the precedent we've set changes, right? If it flattens, a value over here that should be obese is going to read as not obese. And that is going to produce inaccurate results for us. And that's not what we want, right? So do this at your own risk, right? You're going to have a very high error rate, and your line of best fit will shift with large data sets. The data sets that you guys are going to be working with next week, you can do it. It's not advised, but it will work for a very few cases, but not for the whole data set. So what's our solution to this? Well, our solution to this is logistic regression and the sigmoid function. All right. So how does that work? How does that work? First of all, logistic regression and classification. What are the two differences? Regression, the way I like to think about it, especially I really like this image. Regression, what is the temperature going to be tomorrow? All right, what is that exact point on my linear regression line? What is that exact point? Classification, is it going to be hot or is it going to be cold tomorrow? All right, so based on the data that is given, it's going to be hot, it's going to be cold. Also note, you can use regression to classify things as well. That is mainly what we're doing with logistic regression. But for now, keep this in mind as we keep going forward. So this function here is a very accurate representation of what we were doing over here. You can see how that function accurately fits the curve, and how it'll fix our outlier problem. Not always, but it will fix our outlier problem and you'll have a higher accuracy. So let's say my 1 up here is the obesity and 0 is not obese. And if I say 0.5 is my middle line, less than 0.5, I'm going to get a value down here. Greater than 0.5, I am going to get a value up here. Regardless if I have a value way out over, just ways away, I will get a more accurate number. So next week, I know this was kind of short, but it's mainly as a setup for what we're going to be doing next week. So I hope to see you all there next week, where we're going to be covering more into gradient descent, more into the sigmoid function, where you guys will get a chance to do this stuff hands-on, and you guys will get a better sense of what it is rather than me talking to you guys. It'll be you guys learning through actually hands-on code. So I know it says logistic regression project. I'm going to be posting in the Discord two projects later this week, a linear regression one and a logistic regression one. If you guys would like to start working on it earlier, so you can come to us with questions next time. But we'll have all the instructions for you guys, so you guys want to get a head start on that. So you will have the option next time, logistic or linear, or if you want to do both, you can do both. All right, update.
Okay, I already made an announcement about this in the Discord server, but officially, we now have a sponsor for the Sky's No Limit competition. It ends in 20 days, so if you haven't started yet, now would be a very good time to do so. The prizes are as follows. First place is $225, second place is $150, and third place is $100. All of those are going to be decided by a panel of judges that we're hopefully going to have. If that doesn't work out, then all of these are going to be decided by the audience. But right now, the first three are going to be decided by a panel of judges that are going to be brought in, and fourth place will be decided as an audience favorite. The requirements for submissions, I'm going to be announcing a little bit more precisely later this week, but it's effectively going to look like a short presentation, a quick write-up, and then passing along to us your code and data set. Basically, whatever you did to that, so we can actually see that you did the thing. Yeah, I'll be upfront here to answer more specific questions. And then next Thursday, not this Thursday, but the next one, I'm going to be going over example submission. So how you might want to structure your submission for the final deadline, which is on November 27th, I believe, with presentations being on the 28th. I'll also put out a schedule for how we're going to be doing that, just to gauge how many people are interested in doing this. But it should be good. The prize pool is pretty big, so best of luck to everyone who's participating. And then, I could, sure. And then for the last speaker event of this quarter, that's going to be this Thursday, we're going to be having Amit Magani. That's correct? Sure. He's a product lead at Microsoft. The talk is going to be over Zoom from 6 to 7 p.m. this Thursday. I'll be putting out the link in the Discord server 30 minutes out, probably. Should be a lot of fun, and hope to see you all there, virtually, of course. So yeah, I think that does it for today. We'll be up here to answer any specific questions, either about the material today, about the competition for the next while. So thank you all for coming, and hope to see you soon.